Okay, so let's proceed with the third sample problem. Okay, the rocket is fired vertically and is struck by the radar station. When theta reaches 60 degrees, other corresponding measurements give the values r, which is equal to 30,000 feet at that instance, and also the r double dot is 50 feet per second squared, and the angular velocity is 0.02 radian per second. Hinahinay ang angular velocity. It's because nga layo ang satellite and sa rocket. Pero ang rocket yung vertical is dasig-dasig na nito. So the question is, calculate the magnitudes of the velocity and acceleration of the rocket at this point. Okay. A question is magnitudes only. It doesn't ask of the velocity and acceleration. Magsiling niya calculate, solve for the velocity and acceleration, meaning you divide the vector quantity. Pero magsiling niya explicitly calculate the magnitudes, meaning scalar lang some velocity and acceleration in the data. Okay, so let's solve this one. Let's draw the rocket 1.63. Oh, wait. So somewhere is the radar here. This is the rocket. Okay, we have the radial distance, the angular positive distance, the origin. Right, let's complete the given. The givens. The angle is 60 degrees. The angular velocity is 0.02 radian per second. The r at that instance is 30,000 feet, and the r double dot is 70 feet per second squared. So these are the givens now. Now, what is being required of us is the magnitude of velocity and acceleration. So I'll just write along v and a indicate the magnitude of velocity vector and acceleration vector. Okay. Now for the solution, what is the best approach to this solution to this problem? First, we have to understand that the velocity and acceleration are both vertically oriented upward. Meaning, we have to draw velocity here. This is our V, this is our A. I'm not sure if velocity is greater than A in terms of length, in terms of the magnitude, but they're both wordless oriented vertically upward. And these are resultants. So if we're going to decompose these two into transverse and radial axis, we have something like VR here, V theta here. And for acceleration as well, we have AR here and A theta here. So what we can see from this figure is that both VR and V theta are positive because they tend to increase the R and the theta. And the AR and A theta are also both positive because they help VR and V theta. They are not opposing VR and V theta. So those are additional givens. Now what's next? The question is, let's not deviate from the question of the magnitude of the velocity and acceleration of the rocket. So, wala lang. We can solve of course VR, V theta, AR and the data. And once we have those values, we have to solve for the resultant using Pythagorean. Let's try. First, one is a VR. VR is R dot. Do we have R dot? If at that instance R is 30,000 feet and R is accelerating at 70 feet per second squared, and the direction of the motion did not change, meaning R dot must not be zero, because it's only possible na zero R dot if nag-change natin velocity, if nag-change natin motion direction. Let's continue the next segment. V theta is R theta dot. We have 30,000 feet times theta dot, which is 0.02 radian per second. We have 30.02, 600. This is 600 feet per second ang V theta. Ari na, tidak talaga. Primero, dito na-solve ang VR or that. We don't have that. But we have V theta, and we have the angle, which is 60 degrees ari na yan sa dalaw. So if 60 degrees ni siya, this is also 60 degrees, and this is 60 degrees. Okay? So using V theta, actually, it's not necessary na gili para mag-argue because we are pwede na taka-direct from V theta to V because what is recorded as well is the V. So V theta is V cosine 60 degrees. So V in this case is V theta divided by cosine 60 degrees. This V theta is 600 feet per second divided by cosine 60 degrees. So velocity at that point, because it must be greater than 600. 600 divided by cosine 60, 60, 60, 60, 50, 1,200 feet per second. Okay, so that's for the velocity. What about the acceleration? For the acceleration, you need to find AR and A theta. And then, pwede mo nakagamit Pythagorean theorem or pwede man even AR na lang or A theta. And then, try go na lang, simple try. Try to be sa simple lang. This AR is, or that minus, or do we have given for this? Yes, may given to them. So ano yan? Sa A theta yan. Ari walang given. So dito proceed. That is part of that, according to given, is 70 feet per second. Minus R is 30,000 feet. And this is 0.02 radian per second squared. Meron ito isa sa angle na 60 na wala na of course nagamit ito siya. Okay, so planning answer. 30,000 feet times 0.02. Well, 70 minus 10 is 50. So the answer this is 58 feet per second squared. That's for the A theta. So A theta, according to the figure now, to get to A, we have to divide the A theta by cosine 60, which is 58 feet per second squared. 116. I'm not sure if these numbers are correct, so please try to solve. No? Also para may counter check. So these are the velocity and acceleration, the magnitude. Of course, they're both vertically upward. No? That's why wala na siguro gina-ask is because it is obvious na ang sense of direction is upward. Okay, last problem. This is a nice problem, I guess so. Let's read together. A particle moves counterclockwise on a circular path. Oh, ang mabilis na last time ng solve using normal and tangential, but this time, I think we're going to solve it using radial and transverse. I'm not sure. Okay, let's continue na lang. A particle moves counterclockwise on a circular path of 400 feet radius. It starts from a position which is horizontal to the right of the center of the path and moves so that S is equals to 10 t squared plus 20t, where S is the arc distance in feet and t is in seconds. Compute horizontal and vertical components of the acceleration at the end of 3 seconds. Last time, nakita natin sa dream problem. Addition. I'm confused once about 1.64. The same exact question, yet compute horizontal and vertical components of the acceleration at the end of 3 seconds. Pero now, AX, AY. Solve na siya. But can we okay, so ang solution is exactly the same. Ang only difference is the notation used. Kita mo di? So di, if we zoom it, ang AT and AN, if we use your radial and transverse axis, hindi na nasa AT kag AN, kundi may mga sa A theta kag AR. Bali notations lang ang different. Pero ang logic and principles of solving this problem are exactly the same. Because ang problem is the same. Wala mong kinalain. So the problem is the same. We're gonna take the same path na Japan sa ginhimo today. Only that we have to use different notation because play natin na system din gamit. We analyze it from the polar coordinate system. And this from normal and tangent axis. I think that's enough na for this sample problem. It's exactly the same relation. So for the exercise, we have 1.61, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So that's all for today. Thank you for your attention.